Hello everyone, this is the part 2 of one-way ANOVA. I feel that better I can give you the code also, right? Through code also you can understand. Already discussed theory, but that theory, how does theory implemented in code, right? You have to download R Studio. In R programming, how we do one-way ANOVA, that's what I am going to show you over here. So I'll just explain it. Look, there is one-way ANOVA, right? First of all, we have to see the data sets. These empty cars data sets are there in by default. It comes in R. So this data set is like this. Look, this is the data sets which has a 32 entities, right? 11 total columns. It says that. Let me 32 observation. 32 observation means there are 32 responding like this, like this. Then 11 variables means those are the variables you can consider 1, 2, 3, 4, 7, 8, 9, 10, 11. So 11 variable. We consider this MPG variable as a dependent variable, and other variable whatever there, right? Those we consider as an independent variable. So our main test is one-way ANOVA. So you know, right? One-way ANOVA means there is a one continuous dependent variable. This variable with there is one of the variable which should have a categories more than 3 plus, right? We consider 3 plus categories in one-way ANOVA. Now look, I will see the MPG predicted MPG by with the predictor here. I'll consider gear. Based on the gear, how much mileage gives for that particular vehicle, I would like to see, right? Whether there are 3 groups, 4, 3, and maybe there is some 2 is there, right? 5 is there. So 3 categories. This my assumption is I am performing one-way ANOVA. I have continuous dependent variable with independent variable which is in category in nature. This is one independent variable, but there is 3 category, 4, 3, and there's one more 5 is there, right? So I would like to see what I'll compare this variable mean to this predictor, right? Predicted variable mean to predictor. I mean to say how much this 4 gives to this true mean. I will compare. And 4 gives more mileage, or 3 gives more mileage, or 5 gives more mileage. Okay. For that, let's go to one-way ANOVA. One-way ANOVA, we have empty data sets. Already you saw that empty data sets, right? That empty data sets will be stored as a variable as df. So we are not calling as a empty cars. We will call as a df because everything is there in df. View data means I have just shown you that, right? That's that view. So first of all, we need to know the formula, right? According to our software, we can use one-way ANOVA formula as AOV and keep dependent variable with tilde independent variable. Why we use factor? Because it is categorical. That's why we are using factor. Okay. So data equals to this data here. So when we generate summary ANOVA, right? This is the model. And one more thing I told you, right? You should look that MPG variable normally distributed or not, right? We know this is normally distributed. This is the simple linear regression, right? So simple linear regression, we also do the linearity of dependent variables. So it is normally distributed variable. We already know that. That's why we did not perform the check the distribution, right? Whether normally distributed or not. So we directly dependent variable with gear. We have 3 categories, 1, 2, 3. Then we need summary. What summary gives? Let's see what summary gives. See, this is the summary. What summary gives? Summary gives that this model is significant. P-value is less than 0.05. Significant means what? There is difference in mean of each categories to compare of this gear. Got it? Compare of this MPG. So we need to understand that there is a difference, means there is a mean difference. If one unit, one of the pair has a difference or significance, so that's why this comes significance. It says that it is significance. Insignificant means there is no difference in mean. So what we are getting, ANOVA is significant. How we come to know ANOVA is significant? Through p-value, right? P-value. Through this p-value, this model is significant. It says that we may have a different pair inside of it, but there has to be a one pair which has a different mean. Means mileage are based on the category of gear, right? Based on the gear, mileage is different. That's what it tells. This somebody tells, right? If it is insignificant, means based on the gear, mileage is no difference at all. It says, right? That is accepting null hypothesis. Or is accepting alternative hypothesis. So let's go. Now this is okay, but we don't know, right? We are not aware that which pair is a different, right? This says overall model is significant. Means there is one pair which maybe there is one or more pairs which is a significant mean value. Means both comparing means are different, right? Different. That's why we don't know which pair. That's why we use two-key HST test. Two-key HST, we keep that model inside of it. Two-key HST, what it gives? T capital, TU-KEY, HST. HST is whole capital and T capital, right? And giving this ANOVA model inside of it. What it gives? This generate these things. See? Comparison, all this. So you look, 4-3 is significant. 5-3 is not significant. 5-4 is not significant. See? Now what happens? Which is best? You can tell. 4-3 is significant because 4-3 gates are those gates which make the different, which has a different in means. That's what you say. Based on the gate, mileage is different. This 4-3 has a different on the mean. That's what you understand. Based on the gate, mileage becomes difference. This is the one which is significant, right? We saw the overall model is significant, but inside of that there is one value which is significant, that is 4-3 is the best one, right? Out of considering other. So look, now we don't know what is the mean of 4, and out of those two, right? Which one is best? 4-3 is best, you said. 3 and 4 is best, but we need to know which one is best, 3 or 4. For that we have to use t-apply function by keeping MPG as a dependent variable, I think so, with get as independent variable. Then we give mean, right? t-apply $mpg, $get, mean. Then we see individual gear mean. So the best gear means which gives more mileage, individual more mileage, right? So comparing to 16, 24, 21, which one has a more value? 24.53. So it says that this 24 when 4 gear gives 24.53 mileage. You can just say that 4 gives is the best out of those gear, right? So if we use 4 gear means there has to be a 24 mileage in that gear. It is the best out of 2 gear, right? So like that you can conclude this one. Okay, output 4 gear is the best one for mileage. Thank you.